All right, so I asked you there to like find all of the stuff and use it to sketch the graph, but of course you would be, well within your rights to just start by graphing the thing in Desmos or a calculator, right? Because you have it, you might as well use it. That's what it looks like. So, of course, also because I asked you to find all the stuff, I'm gonna want to see that you know how to find all the stuff, right? So what I would take from the graph, I mean, apart from like general shape and stuff, is that there are sort of three like chunks or pieces to the graph, right? So there are two places where it's not continuous, here-ish and here-ish. And at both of those places, we've got a vertical asymptote happening, right? Clean like vertical break in the graph. You can like imagine a vertical line fitting in there. So there's a couple of those. We're talking in behavior, the ends appear to be like leveling off, right? They're pointing, sort of horizontally out. So that tells me there is a horizontal asymptote. It looks like it's pretty close to the x-axis, right? It's not like, way up here or something, right? Now, again, I don't really know yet, just by looking at this, whether it's 0 or like, I don't know, 1/12 or something, right? I can't tell that difference just visually, but it looks like it's probably pretty close to the x-axis. And then looks like we got some intercepts and stuff. So let's go find the things. How do we figure out like domain and any discontinuities? Look at the denominator and set it equal to 0. Set the denominator equal to 0. Okay, so setting the denominator equal to 0 gives you 5 and -1. Those are places where the function is not continuous, right? Because it's not defined, because you get 0 in the denominator, you can't divide by 0. Now notice also here that x minus 5 and x plus 1, these two factors that show up in the denominator, only show up in the bottom. They're not also in the top, right? So there's nothing that would like reduce out or cancel. 5 or -1, just give you some number in the numerator, not 0. That means that at those points we get those vertical asymptotes that we saw. And again, I might like flip back to the graph and just look and say like, okay, -1 and 5. Yeah, that looks about right for where those breaks in the graph happen. Okay, so the domain is everything except those two values. And are we sort of getting to the point where we're comfortable enough with that I can just kind of write it down and we're good to go? Okay. All right, domain there. There are vertical asymptotes. Again, because those are zeros of just the denominator, not the top and the bottom, or because on the graph I see that there's that asymptotic behavior happening there that the graph sort of breaks vertically at x equals 5 and x equals -1. Okay, so that's that. So done. Next thing, in behavior. How do we figure out if there's a horizontal asymptote and if there is, where it is? The degree of the top and the degree of the bottom, right? Horizontal asymptotes are talking about in behavior, what happens out there, not in the middle. So what happens out there, the in behavior, we want to look at the leading terms. Here, that would be x in the numerator and x squared in the denominator. X over x squared, right? The reason that I separate just those out is that now I've got a simpler thing that I can like do algebra with, and it's a little bit less to think about. I can figure out better what's going on with that. X over x squared would reduce to 1 over x, right? What does 1 over x do when x is big? heads to 0. Right, now again, thinking back to like the graph that we've already seen a picture of. That means that the farther out we go, the more this thing kind of flattens out, and as it does, it's approaching 0. So that's what's happening here and here. Because you're essentially taking 1, but any fixed number, right, and dividing by, well, x. We're talking about what happens as you go out that way, as you let x run to positive or negative infinity. So if you take a fixed thing and divide by a thing that can be as big as you want, well, you're going to get small numbers back, right? So there is a horizontal asymptote. Y equals 0. Everybody good so far? Yeah, does anybody have any questions about anything? Okay. All right. How about intercepts? To get an x-intercept, you x-intercepts are where you cross the x-axis. So every point on the x-axis, what do you know? Y has to be 0. Y-intercept, every point on the y-axis, what do you know? X has to be 0. That's not here, that's everything in general, right? That's what we mean when we use the word intercept like that. We mean x-axis or y-axis. So the other one is 0 then, because that's how we set the thing up in the first place. So if we let y be 0, but the only way this could possibly be true is if the top is 0, right? Because the bottom can't be, because we've already dealt with that, right? Dividing by 0 is undefined, so it can't be from the bottom being 0. And the only way to get 0 when you divide, a number by something is if the number you started with was 0. So -2, -2. That's your x-intercept. For the y-intercept, just plug in 0. So 2 over -5 times 1, -2/5. So you can read it. So those are your x and y intercepts. Okay, so that's all the stuff that we can, sort of, I'm gonna say easily. I don't mean like there's nothing going on here, right? This is no big deal. I just mean that none of the individual things were all that hard to like dig in and find once we kind of know what we're looking for and what it means. We've got all this stuff in. I could sketch the graph out by sort of framing it with the asymptotes, right? Draw those vertical and horizontal lines, place those points down. There and there. And then, again, we would just kind of like fill in the graph from, looking at it in a calculator or something. So vertical asymptote there and there, horizontal one there. Notice there is a place there where that crosses that horizontal asymptote. Again, that can happen. Doesn't have to, only happens on the left-hand side, not on the right-hand side. But it kind of dips below and then comes back in. I would say that for something like, you know, a test question or whatever, I'm probably more likely to give you a graph and have you tell me about the things, right? With kind of the same, you know, ideas in place as the like first page from the test I handed back, that, you know, assuming that things are like what they appear to be, right? So what I would look for is, well, any asymptotes, those tell me something about the denominator. Horizontal asymptotes tell you something about what's going on, intercepts, you know, all that kind of stuff. So kind of working the other direction as well. Okay, feel good for now anyway? Okay. The horizontal one? Yeah, so horizontal asymptotes, again, don't really tell us about anything that's going on in the middle. They tell us about what's happening out there. So you can cross those because they like work a little bit differently, and we're getting it pretty far into the weeds to look at like why and when that happens and that kind of stuff. So don't sweat that part too much, but yeah, they happen for a different reason. So sometimes you do cross over those vertical ones, you can't for kind of several reasons, but mostly because that's where you divide by zero. Yeah. Okay, cool. So there's all that. Again, 5.1 and 5.2 homework stuff is all the graphing and domain and asymptotes and all that stuff. I looked this morning and a lot of y'all had already like knocked it out, which is great. If not, then, you know, just make sure to, again, get on that. You know, today would be a good time to, you know, probably do it so that, you know, tomorrow if you have any questions. Anyway, the next couple of days, we're going to look at solving equations. Okay, so what happens when we have some kind of equation, and admittedly this looks like a lot, but it's not going to be as bad as maybe it looks at face value, but where we've got some kind of rational thing, maybe more than one of them, and we're trying to solve an equation, right? So find values of x that make this thing true is what we're trying to do. We know some stuff individually about the like pieces, right? Like if I just looked at this piece all by itself, what's one thing we could say kind of right away about that, just at a glance? What's one of the really big things that I keep coming back to and writing in like scary like red letters and stuff? X can't be -2, because if x is -2, you've got 1 over 0, that's a problem, right? Okay, so x can't be -2. It also can't be -7 because of this, right? Because even, you know, in trying to solve this equation, that stuff still like matters, right? This can't possibly have x equals -2 as a solution, because if it did, you'd have a thing somewhere where you're dividing by 0. That doesn't work, right? So even if I like manipulate stuff and do algebra to, you know, make this look nicer, which is basically what we're going to do, right? We're going to do some algebra stuff to make this look friendlier, to turn it into something that we know more about solving. Even if we do that, the sort of, you know, through line, like where we started, still matters. So whatever else happens, -2 and -7 aren't going to work here, right? So we're going to have to sort of keep that in mind, because sometimes when we do algebra stuff to manipulate and to make a scary looking thing look less scary so that we can solve it, we either lose track of stuff that was there to begin with, or we can also like introduce kind of like false positive like information that wasn't there. So that's one thing we're gonna have to watch out for. First though, how are we going to do the algebra? The way that we're going to do this to like work with and manipulate these fractions to get them to a place where we can solve is by making them not be ugly, messy, horrible fractions anymore, right? The way that we're going to do that is with the least common denominator. So maybe recall finding a least common denominator. If you want to add a half and a third, what do? Make the denominators the same, right? The reason I can't just do it directly is that they're different kinds of things. I think about it as, slices of the pizza or whatever. This means you take the whole thing and cut it into 2 pieces and you take one of them. Here you cut it into 3 pieces and you take one of them. Well, if you're going to add them, you need to make them be the same kind of thing, right? You put them into sort of a common unit. So we need to make the denominators the same. How do we do that? Multiply a half, and even just look at the denominator, multiply this by 3 and this by 2. Why? Yeah, basically you got to go up to a common multiple, right, for 2 and 3. The smallest of those would be 6, right? You could go to 12 or 24 or I don't know, a billion. But typically we try to go to the smallest one so that we don't have to do work reducing on the back end. So multiply this by 3. Multiply this by 2 because that's going to take us up to 6. So that we don't change anything, no, we do it on top and bottom, right? So this is basically saying, how many sixths are in a half, right? Or if I took that pizza that I cut it into just half, if I cut it into sixths now, well, how many of those would be in the 1/2 I was keeping in the first place? 3 over 3, 2 over 2, those are both equivalent to 1. So we're not changing anything. This is 3/6. This is 2/6. Sixths is hard to say. Sorry, I can hear it whistling and anyway. And then add those together, right? Now they're the same kind of thing. So we just add across the top. Everybody's cool with that? Okay. I know we're going sort of way back, but we're going to, use this idea. So I want to make sure we really understand what's going on more than just I kind of halfway remember how to do this thing. Make them the same kind of thing so that you can combine them. And the combining part is just across the top because the bottom is just telling you what kind of thing it is. Okay, so that's how you find a common denominator. So the LCD here would be 6 because that's the smallest thing that 2 and 3 both go into. What would the LCD, the least common denominator, be for these 2 things? Hey, you know what? Let's even, let me kind of take that idea and make it look more like what we just did. Adding those together. Say I wanted to add those 2 things together. So we need to find a common denominator to do it, right? What would the common denominator be for this thing, where the denominator is 3x minus 1, and this thing is just a whole number 2? How would we do that? You can write that as 2 over 1. That helps, right? Sort of force yourself to think about the whole number 2 as a fraction. Okay, then what? What we need is a common multiple for this thing and this thing, right? It doesn't really matter that it's 3x minus 1. What if it was just 3? What would the smallest common multiple for 3 and 1 be? 3, right? What if it was 3x? 3x, right? Multiply them. So, well, it's actually 3x minus 1. So what's the least common multiple for those 2 things? Which makes it the least common denominator for the fractions. Multiply them. 3x minus 1. right? The tool that you have to work with here is that you can multiply by 1 whenever you want, right? Now you can write that 1 as 2 over 2 or 3 over 3 or 3x minus 1 over 3x minus 1 or whatever. But multiplication is the tool that you have to work with. So the way we find the least common denominator is building it up with multiplication. So the denominators that I need to sort of cover or like incorporate are this and this. So to get them both into terms of that common denominator, what do I need to do with the first term? Anything? Or is it already there? It's already there, right? It's already got the denominator that you want. What do we need to do with the second one? Multiply by the stuff you're missing. Right? This is the same way I would do this if I was adding a half and 2. That, because that's a mess. Any other fraction adding to a whole number, I just figure out how to write the whole number in terms of that same fraction. That's the same thing that we're doing here. It just, looks a little scarier because it's an algebraic thing. Okay, so x minus 2 over 3x minus 1 plus which is what, 7x minus 4. I didn't really, I don't really care where it ends up. Mostly focused on just this first part, figuring out what the common denominator would be. But once you do that and sort of multiply in what you're missing and rewrite it, then to add them, you would just add across the top, right? So x minus 2 plus 6x minus 2 all over that common denominator we just found, and then just combine like that. Okay, so what is the least common denominator here? Where could we start? Let's think about, just for one more second, think about a kind of more familiar example. If those were the denominators that you had, 3 and 2 and 5, how would you find the least common denominator for them? What kind of fraction can I, how can I rewrite all 3 of those things as the same kind of fraction? Multiply them together, right? Smallest common multiple, smallest thing that they all go into. Well, if you multiply them all together, you get a common multiple. And then, you could maybe like check to see if anything got sort of double counted, right? So for 3 and 2 and 5, it would be 30, right? 3 times 2 is 6 times 5 is 30. If it was 3 and 2 and 6 or something, well, I could multiply them all together and go to 36, but really, there are smaller ones that they all go into, right? Like all of those go into 6. So I don't have to go all the way up to multiplying them. Okay, so what about for these algebra things? We don't care what's going on in the numerator, right? Simplify stuff where you can. There's an x plus 1. And I got to treat that like it's, sort of a whole, like one thing, right? And there's an x minus 1, and there's an x squared minus 1. Okay, so thing A if you want, thing B if you want, because those are different, right? So like each of those is going to have to be in there somewhere. What about this though? How else can we write x squared minus 1? Is that factor? It's the difference of squares, right? So can you find the like B term is 0 if you want? Can you find things that multiply to -1 and add to 0? -1 plus 1 will work, right? Okay, so one of the terms, the denominator is x minus 1 times x plus 1. This one. This term, the denominator is x plus 1. This term, it's x minus 1. What is the least common denominator for those three things? Something that they all go into, or something that we can, sort of build up to using just multiplication. This, and this, and this. Okay, let's try the simpler number example again. This was 2 and 3, and this was 2 times 3. What would the least common denominator be? 6. 2 times 3, right? Okay, so what is it here then? Just that, right? You got one thing, a different thing, and then the product of those two things. Well, this would be the least common multiple for those two things then, right? Because it's just thing A times thing B. All right, so what about that, the next one, this one? Got x plus 2, I got x plus 7. What's this? Can you factor it? You find two things and multiply to 14 and add to 9. What are they? 2 and 7. Okay, so we've got these two things that match. X plus 2 here and here. X plus 7 here and here. This is the product of those two things. So what's the common denominator? Common multiple. X plus 2 times x plus 7. Right? Because if I'm trying to write these all as the same kind of fraction, and if the tool I can use to do that is multiplying by stuff that's not there, right? As long as I do it on top and bottom. I can get from here to there by multiplying this first term by what? X plus 7 on top and bottom, right? I can get from here to there by multiplying the second term by x plus 2 on top and bottom. And here I don't need to do anything because it's already there, right? So again, if it helps you to look at these as, try not to get hyper focused on the like x plus 2, x plus 7, that part. Those things are the same. Those things are the same. So you can get from here to there by multiplying by the, purplish scribble thing that's missing. you can get from here to there by multiplying by the orange triple-ish thing that's missing. So the least common denominator is orange thing times purple thing then, right? If that helps you, cool. If not, then just don't even worry about it. Okay. This one we already talked about, but the LCD would just be 3x minus 1 because that's the only thing that's there. What about that last one? Smallest thing that x squared and x and 1 all go into. You gotta go the other way, right? We have to like build stuff up. You use multiplication to, sort of add stuff onto it. So instead of taking sort of everything down to 1, you got to take everything up to x squared, right? I can get from here to x squared by multiplying top and bottom both by x, right? I can get from here to x squared in the bottom by multiplying top and bottom by x squared. And then this one I can just leave alone, right? But I can't divide stuff out. I have to multiply stuff in. Okay, so that's how we find the least common denominator. Now, what we do with it is use it to basically make our lives a little bit better by multiplying out all of the fractions and sort of like clearing everything out. So what is the least common denominator here? The things we have to begin with are x minus 2 and x plus 2 and x squared minus 4. And x minus 2 times x plus 2 is x squared minus 4. Right, so this thing factors as x minus 2 times x plus 2. And that's not necessarily that like I'm really good at factoring fast, but these things, probably a good place to start thinking about trying to factor something like this is what happens if I multiply this by this? Get x squared minus 2x plus 2x, so those drop out, minus 4. Oh, okay, so that factors into this. Okay, cool. The least common denominator then is, well, just that. Okay. Now, what I'm going to do with that, there are kind of two ways that we can like think about this. I can either use it to actually rewrite all of the fractions and then sort of go from there, or we can also use it to just sort of like get rid of all the fractions. I think that's the easier way to sort of look at it. So what I'm going to do is take this equation. Hang on, I want more room than that. And multiply both sides by that LCD. There we go. Multiply both sides of the original equation by that common denominator. What happens then is that on the left, you got to distribute because you're adding, right? So it's this times x minus 2 times x plus 2. Same thing here and same thing here. And that looks like a lot, right? But take a look at it one piece at a time, one term at a time. What happens there? Before we start actually like trying to multiply things out or anything, what happens there? You cancel, right? There's a factor of x minus 2 in the denominator, and you're multiplying by x minus 2. So those cancel. When you cancel those, what's left? X, the thing that was, there to begin with in the numerator, times x plus 2. Well, that's not as bad as it looked at first, right? Okay, do the same thing the rest of the way, through the rest of the terms. So what happens with this second big, group of stuff? 1 over x plus 2 times x minus 2 times x plus 2. What happens there? The x plus 2 cancels out. What's left then? 1 times x minus 2. And of course, the multiplying by 1's not really going to matter, right? I'm just leaving it there for, emphasis. Okay, and on the other side? X minus 2 cancels, and x plus 2 also cancels. And what's left is 8. Okay, so let's just kind of walk back through that real quick. We figured out the least common denominator by looking at what was there to begin with, right? The kinds of fractions that we had, the denominators that we started with. We found the least common denominator. We multiplied the whole thing all the way across each term by that LCD, which looks like a mess for a minute, right? It looks a lot worse for a second, but then when you look a little closer, stuff starts canceling kind of all over the place, which makes sense because we took a bunch of fractions and multiplied them by, their reciprocal basically, or, sort of reciprocal and some other stuff. So a bunch of stuff cancels. We get this. Well, now what can we do with that? All the fractions are gone now, right? This is x squared plus 2x plus x minus 2 equals 8. What kind of a thing is it? You thought they were gone. They're never gone. Yeah, so we just have a quadratic to solve now, right? Which is okay because we know about solving quadratics, right? Maybe factors. If not, we can use quadratic formula. Y'all take it from there. But when you solve that, so you go home, finish working through that thing, and read through the sort of that paragraph, those 2 paragraphs, I guess, at the bottom of the page there, and think about what's going on and like where we sort of started this discussion with what can I tell about this, just kind of right off the bat by looking at it. Okay, so y'all finish that up. Basically, again, just kind of finish the stuff on the first page there. Tomorrow, we're pretty much just gonna kind of work some problems and see how all this stuff works out in different cases and stuff like that. That is all I have to say. If you have any questions or need help with anything, let me know. Otherwise, you have a good day, and I'll see you tomorrow.